Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 12, Lesson 3 on probability and percent. So far we have been measuring probability by using probability ratios. That's always a fraction where the denominator is how many equally likely outcomes we have in a particular problem, and the numerator is how many of those outcomes fall into the event that we're trying to find the probability of. So, I roll a die, what's the probability I get a number greater than 4, right? Oh, there's 2 numbers out of 6 that are greater than 4, so the probability is 2/6 or reduced down to 1/3. All right, but often, very often in the real world, probabilities are expressed in terms of percentages, right? And that makes sense, right? We looked at how to convert ratios, right? Just a normal ratio out of whatever into ratios out of 100, because that's what a percent is. So let's start to get into that idea of measuring probability with percents. Now, before we get into that, we want to talk about the probability scale. Now, probability measures the chance or likelihood that something's going to happen, and it's measured on a scale from 0 to 1, right? Where 0 means the thing is impossible, and 1 means it's guaranteed, right? It's going to happen, right? Gonna happen. So let's take a look at exercise number 1. To rate the likelihood of an event, the probability scale goes from 0 to 1. Label each of the probability scale's 5 sections with one of the following: HL, highly unlikely, HL, highly likely, HU, highly unlikely, SL, somewhat likely, SU, somewhat unlikely, and N, neither likely nor unlikely. Now again, remember, right? Maybe we'll even write this down right now. Let's try that again. Right, 0, this is basically means that something is impossible. And this little sucker right here means it's guaranteed, right? So those are our 2 extremes on our probability scale, from impossible to guaranteed. These little kind of brackets down here are what I want you to list these things on. So why don't you pause the video now and tell me what you think each one of them, or where you think each one of them goes. All right, well, I'm going to kind of start almost in the middle. Right around here where we have a 1/2 probability, right? That's when something is neither likely nor unlikely. If I told you that the probability that it was going to snow tomorrow was 1/2, well, maybe it's going to happen, maybe it's not going to happen, right? It's neither likely nor unlikely. That means everything down here is sort of the unlikely side of things, and everything up here is the likely side of things. Now, what is highly unlikely? Well, those are probabilities down here on that lower end, from 0 maybe up to a little bit before 1/4. How close to 1/4? It's kind of more of a feel. So down here we're talking about highly unlikely. And on the other end of the scale up here, probabilities that are getting very close to 1, those, I would say, are highly likely. But of course, you also get these probabilities that are less than 1/2, but not highly unlikely. Like a probability of 1/3 or something like that. That would be somewhat unlikely. If I had 3 cards, an ace, a queen, and a king, and I said, pick one at random, what's the probability you're going to pick the king? Well, it's only 1 out of 3. That would be somewhat unlikely. It wouldn't be highly unlikely. It's not like, oh my gosh, I'd be so surprised if I got a king, right? On the other hand, if I had all 52 cards in a deck and I said, pull one out, what's the probability you get the ace of spades? Well, that would be 1 out of 52, 1/52nd. That would be highly unlikely. If you pulled it out, you'd probably be like, wow, that's pretty amazing, right? Now, on the other hand, up here, right, these are the somewhat likely events. Right. If I said the chance that it's going to rain tomorrow, let's say, is 6 in 10, 6 out of 10, well, that's somewhat likely. It's more than a half, right? But it's not like it's way up here or anything like that. Okay? Now, this is still the probability scale based on fractions. What we now want to do is start to think about the probability scale in terms of percents. Let's get into that in the next exercise. Because of the connections between fractions and percents, it's common to use percent to indicate probabilities, not probabilities, but let's say to indicate probabilities and likelihoods. Okay? And it makes sense because keep in mind, right, from our unit on percents, all a percent is a ratio out of 100. Since we've been dealing with probabilities as ratios, simply having the denominator as 100 doesn't seem all that strange. Let's take a look at exercise number 2. Let me just move that out of the way. Above each of the 5 numbers on the probability scale, write a corresponding percent by changing each fraction into 1 with a denominator equal to 100. All right, so let's do a few of them together, right? 0, well, 0 is the same as 0 out of 100, so that's 0%. And that makes sense. The number 1, right, which is really as a fraction 1 out of 1, which is equal to 100 out of 100, well, that's 100%. And probably most people feel a lot more comfortable saying that the probability of something happening is 100% versus the probability of something happening is 1. That just sounds strange. Yeah, the probability it's going to rain tomorrow is 1. Right? I mean, can you imagine a weather forecaster saying that? Right? But it makes a lot more sense for the weather forecaster to say, well, the probability that's going to happen is 100%. Now the other ones, right? So what's 1/4? Well, 1/4 is the same as 25 100ths, right? If I just multiply both the numerator and the denominator by 25, right, I'd get 25 100ths, which means that 1/4 is the same as 25%. Right? 1/2, likewise, is the same as 50 over 100, so 1/2 is 50%. And we kind of knew that, right? And 3/4, right, is the same as 75 out of 100, so 75%. And now it's a lot easier to start talking about this highly unlikely, somewhat unlikely, neither likely nor unlikely, somewhat likely, highly likely kind of thing, right? So you're getting a highly unlikely when you're talking about probabilities that are like, I don't know, maybe 0 to 15% or something like that. Then it's somewhat likely when it's maybe 15% up to, I don't know, 30%, 40%. Then it's neither likely nor unlikely if you're in that kind of 40% to 60% range. Then somewhat likely, 60% up to like maybe 75%, and then highly likely when you're kind of like 80% and above, right? If I were a kid and tomorrow I knew that it was an 85% chance of snow, right, I'd be like, all right, it's highly likely that I'm going to get to stay home from school. Or, you know, maybe you're getting home to stay home from school for some other reason. Who knows? All right, so let's take a look at that probability scale now in light of another problem. Let's take a look at exercise number 3. If an event has a probability of each of the following, then rate it as highly likely, highly unlikely, somewhat unlikely, or neither likely nor unlikely. Okay, so lots of choices there. Let's take a look at one of my favorite, letter A. The probability that the New York Knicks will make the playoffs in 2021 is 5%. All right, well, 5%, that's way down in this area, right? So that would be highly unlikely. Now, for all of you Knicks fans out there, I've been a Knicks fan since the mid-1990s, right? So don't get me wrong. I wish this was more in that 95% probability range where we could say it was highly likely, but let's be honest. All right. So what I'd like you to do now is I'd like you to take a look at the last 3 scenarios, and I'd like you to give them one of these 5 ratings, right? Highly unlikely, somewhat unlikely, neither, somewhat likely, or highly likely. Pause the video now and give a ranking to each one. All right, so letter B. The probability it's going to rain tomorrow is 80%. That's getting up here, right? That's starting to be the highly likely scenario. I mean, it's kind of close to the somewhat likely scenario, but I'm going to go with highly likely. 80% is pretty good, right? You know, if there was an 80% chance that I was going to pass a test, I'd say that's a pretty highly likely chance I'm going to pass. Now, take a look at letter C. The probability that Elsa will make a free throw is 68%, right? Now, 68%, that starts to be down here in this kind of somewhat likely range, right? It's definitely not just neither, right? 68% is pretty good, but still, you know, we wouldn't be shocked if she missed a free throw. So I'm going to say somewhat likely. And the probability that Jaden will sleep in is 40%, right? Well, that's actually less than half, right? But it's maybe somewhere around here. So I'm going to actually say that that's neither likely nor unlikely. Neither likely nor unlikely. Any probability that starts to get pretty close to 50%, right? And I think 40% is close enough, right? Is neither likely nor unlikely. Okay. So now these really are somewhat of a matter of opinion, especially when you get to that kind of gray area, right? So like 95% that something's going to happen, unquestionably highly likely. 5% something's going to happen, definitely highly unlikely. 50% something's going to happen, definitely neither likely nor unlikely. What gets a little bit trickier is if you're kind of at the boundaries, you know, somewhere between, you know, highly likely and somewhat likely, right? Then it becomes kind of a, well, can you justify your choice sort of thing, all right? Anyway, let's work a little bit more with other probabilities and actually come up with some probabilities using percents instead of just ratios, okay? Now, we should be able to express probabilities using percent because a percent is just a ratio out of 100, right? It's just an equivalent ratio where the denominator is 100 instead of 8 or 4 or 7 or whatever. So let's see how we do that in exercise number 4. A game board spinner is divided into 8 equally sized sections as shown below. The pointer is spun once. Answer the following questions. Express your probabilities first as fractions out of 8 and then as percentages. All right, so let's do one right away. Right, letter A. What is the probability the pointer lands on an even number? All right, easy enough, right? There are 8 equally likely outcomes. 4 of those are even, 2, 4, 6, and 8. So my probability, right, in terms of an unreduced fraction, right, first as fractions out of 8, right, that's going to be 4/8. All right, but we also want it as a percent. Now, probably many of you can immediately turn this into a percent, okay? But if for some reason you don't see that this is 50%, then what you might want to do is reduce your fraction, right? That would end up being 1/2. Which then, if we convert that into a percent by multiplying both top and bottom by 50, I'd find 50 out of 100, which would tell me 50%. There's a 50% chance that the pointer will land on an even. And that makes sense, right? 1/2 and 50% are equivalent ways of expressing the same chance. Now let's take a look at letter B. What is the probability the pointer lands on a number less than 7? All right, see if you can figure out this probability, both again as a fraction out of 8 and as a percent. Well, we're looking for the probability that the pointer lands on a number less than 7. That means 1, 2, 3, 4, 5, or 6. So as an unreduced probability, that would be 6/8. All right, good enough, right? But if we want it as a percent, we need to convert this into percent. Now, one of the things that's helpful is oftentimes reducing your fraction to its lowest terms. That's 3/4, right? I'm just reducing my ratio down to the simplest form I can get it. Now I want that out of 100. So just like before, I'm going to multiply both numerator and denominator. I'm going to find that that's 75 100ths. And then that tells me that there's a 75% chance the pointer is going to land on a number less than 7. Okay, so that's it. You know, I mean, in terms of just converting, right, probabilities that are in terms of these ratios into percents, it really takes us back to our, granted, short unit on percent work, where we simply have to convert a ratio that isn't out of 100 into one that is out of 100. So let's get some more practice on that in the next few exercises. Exercise number 5. In a gym class with 50 students, 7 of them can do 10 pull-ups. If a student was picked at random, what is the probability that they can do 10 pull-ups? Express your answer first as a fraction, then as a percent. All right, this is really no different than me asking what percent of the students can do 10 pull-ups. That's it. It's the same question, right? The fraction that can do 10 pull-ups is 7/50ths, right? And so that's my probability in terms of a fraction, right? There are 50 total equally likely outcomes, right? All the kids. 7 of them fall into the category I care about, i.e. that they can do 10 pull-ups. So 7/50ths is my probability in terms of a fraction. But if I want it in terms of a percent, then I'm going to take my 7/50ths, I'm going to multiply by 2 in both the numerator and denominator to get 14 100ths, and that means that there is a 14% probability that I will pick a kid who can do 10 pull-ups. I would not have been that kid. I still wouldn't be that kid. I can't do 10 pull-ups. But that's the whole idea, right? Let's take a look at exercise number 6. A basket has 40 apples in it. Of the 40, 18 have bruises. If an apple is picked at random, what is the probability it has a bruise? Express your answer as a percent. All right, so again, this is no different than if we had been back in the percent unit and I had said, what percent of the apples have bruises? Well, the first thing you'd want to do is simply set up the fraction of the whole that represent those that have bruises, and that is 18/40ths. All right? That would also be a completely acceptable way to represent the probability of getting an apple that has a bruise. But we want our answer as a percent. Now, here's one of those harder problems though, right? Taking us back to the percent unit, where I can't really just look at it and say, well, I just, what do I multiply 40 to get a 100 in the denominator? So when that's the case, when you can't just immediately scale the denominator so that it becomes 100 easily, then you should always reduce your fraction to lowest terms so that you can then scale that. So the first thing I'm going to do is I'm going to reduce this fraction to its lowest terms, and I'm going to get 9/20ths. That would also be a perfectly good way to express your probability if they didn't ask for it as a percent. Now I can scale it pretty easily up to 100, right? Because I can multiply both the numerator and the denominator by 5. That will give me 45 100ths. And so that tells me 45% is the probability that if I pick an apple at random, it'll have a bruise. By the way, if you then had to talk about how likely it would be that you'd get a bruise, you'd say it would be neither likely nor unlikely because we have a probability that's close to 50%. Just thought I'd toss that one in there. Let's do one more. All right, exercise number 7. In a room full of 30 kids, 6 of them write with their left hand. If a kid is picked at random, what is the probability they write with their left hand? Express your answer as a percent. All right, why don't you go ahead and try to do this one on your own. All right, simple enough. 30 equally likely outcomes. 6 of them fall into the category, right? 6 of them fall into the category that I care about, i.e. that they write with their left hand. So the probability would be 6/30ths. Again, 30 is one of those numbers that's not particularly nice in terms of scaling easily to 100. So maybe I'll divide both numerator and denominator by 6. That will give me a probability of 1 in 5 or 1/5. Right, now I can try to scale that thing up to 100, which I can by multiplying numerator and denominator by 20. That'll give me 20 100ths. And then that tells me that the probability of picking someone who writes with their left hand is 20%. Which, by the way, would be a somewhat unlikely thing to do. So if I were just, randomly grabbing a kid out of this group, it would be somewhat unlikely that I would pick one that was left-handed. right? That's what that 20% would tell me. All right, let's wrap this up. So today, we kind of looked at a couple things. We more formally looked at what's known as the probability scale, right? And that's kind of this very informal way of saying whether an event happening is really unlikely, highly unlikely, or somewhat unlikely, or neither likely nor unlikely, or somewhat likely, or highly likely, right? And again, as I said, this is kind of a feel for things. Now, granted, you would never want to say, oh, the probability that it's going to snow tomorrow is 70%, well, then it's highly unlikely it's going to snow, right? That's just out and out wrong. Right, if you say 70% means that something is highly unlikely. All right, so we looked at that probability scale, and then we also looked at how to measure probability not as just a ratio of the number of outcomes you care about divided by the total number of outcomes, but also how you put that in terms of a percent by converting that ratio so that it's now out of 100 instead of out of what it normally would be, out of 8 or 12 or 30 or whatever the total number of outcomes you have. Now you kind of put it in terms of 100 total outcomes and how many of those 100 fall into the category that you care about. All right, well, we're going to do one more lesson on probability. Until then, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.